Alright, here's the first one where I try to take on the super huge review packet. I'm starting on page, I believe this is page 6. It's the one that starts like that. I think this is, yeah, this is page 6. That has the title on it. The other stuff before page 6, the answers are at the bottom. So if I get to those, I just didn't want to do those first because I figured there was a better, stronger need for something like this. Actually, there's no picture for this. I just drew this. It says find the surface area and volume of a regular pentagonal prism with side length of 8. And sorry, I just think I accidentally paused there for a second. Let me start over here, or continue. The side length is 8. So for both surface area and volume, I do need to know the area of this pentagon, and that's kind of annoying. We haven't done anything like that in a while. We did that in, that's really small. Why did I have to draw that so small? We did that in the last chapter a whole lot, but not recently. All right, let me change colors. Yeah, so I have to find the apothem. If I'm going to do area of the pentagon, I want to know the apothem and the perimeter. The perimeter is not bad. The perimeter is going to be 8 times 5, which is 40. The apothem is not something I know yet. Apothem is in this right triangle. Just re-highlighting this one here bigger so you can see it. That would be 4, of course, because that's half the side. This angle I know because it's part of a regular pentagon. You can think of how each wedge of the the 5 parts in the 360 here. It's going to be 1/5 of 360, but that I'm dividing also in half. So this is really 1/10 of 360, so this is 36 in here. And I'm interested in this side, the A. I really don't care about the R. For either surface area volume, I really don't need it. I just need this one. So what I need to know about is the tangent of 36, because what I have there is the opposite and adjacent. I have opposite and adjacent. So 4 over the tangent, if I solve that for A, is what I need. Okay, so this is half times 4 over tangent 36 times 40, which should reduce to, I don't know, something gross. The half and the 4 cancel a bit. I get 2, it's 80. This is going to equal 80 over the tangent of 36. That is the area of the base. Okay, just file that away. I'll use a calculator when I need to. I'm kind of running out of room already, aren't I? Wow, this is a bad one. Glad I'm doing this on video. Did that destroy anything? I'm going to write over here now. Alright, so I guess we could do lateral area first. Lateral area, let's do surface area all at once. Surface area is going to be lateral area plus 2 bases. This is just a regular old solid. I can just find this the old-fashioned way. Lateral area is perimeter times height, and the base I already just found out. It's over there. It's this thing. Perimeter is easy. Perimeter is 40. That's a 4. Times height, which is 35, plus my 2 bases. Okay, now it's calculator time. 40 times 35 is 1400. Plus 2 of these, so it's 160 over, oh, you know what? I'm in radians. This thing resets a lot. Okay, make sure you're not in radians. 160 over the tangent of 36. And that's 220. Point. Am I really in radians? Here's a good way to check. Yep, I'm in radians. 220.22. Okay. Plus 1400. Oh, I messed that up, didn't I? I shouldn't have done this just for fun, just to impress you. I should have kept this in here. No, I put a 4 in there, people. All right. That's 1620.2. Well, that was fun. Volume is going to be extremely easy at this point. Volume is just area of the base times the height. Area of the base is that. So height is 35, so I go 80 times 35. What is going on with the numbers before 0? Really? Hello? I hope you saw my click. I did it. 80 times. You can probably hear my clicking. It's not going. 2800 divided by the tangent of 36. And I get 3853.87. I know it's fun to watch someone else use a calculator. Did I write that down right? It was pointed out to me that I copied wrong from the calculator in a recent other video. See, I did it again. It's 8.7. Okay. Okay, find the volume of the truncated cone. That would be the thing down here that I care about. Find the volume of the truncated cone. I guess this is this dotted line kind of indicates to you that it doesn't really exist. I just want that part. I just want this part down here. But I do need to care about this. I'll show you why in a second. If the height of the removed portion, well, they told me about that. The height of the removed portion is 10. Leave your answer in terms of pi. Okay. Well, I'm trying to find the volume. I think the plan here is going to be, I'm going to say big cone volume minus top cone volume is going to give me truncated cone volume, which is what I need. All right, so top cone volume is not bad. I've got the base and the height. I mean, all you need for this is area of the base times height times a third. So that's no big deal. But I'm missing something here. It'd be kind of nice to know that the height of this whole cone here. Well, I don't know that. But I know that I have, since these things are cut with a parallel base, that's in the definition of truncated. You can assume those are parallel. I have similar triangles right here. If that's 10, this is 2, because that was a diameter of 4. This is 4, because it's a diameter of 8. I can go 10 is to 2 as the whole thing is to 4. Let's do that right here. 10, let's call this x. It's not really a height, it's kind of part of a height. 10 is to 2 like 10 plus x is to 4. First thing I want to do is reduce this. This is 5 and 1. So 20 equals 10 plus x. So guess what, kids? X is 10. That's nice. It won't always be quite that nice. But the important thing actually is not so much that 10 is x, but that this whole height is 20. So volume of big cone, 1/3. I said 1/3. Did you see that? 1/3 pi r. Careful, we're in the big cone now. Squared times h minus 1/3 pi. Now I'm in the small cone. 2 squared h is what I need. This is, I kind of just have to do this, don't I? Because I have to subtract, so I can cancel stuff. 16 times 20 divided by 3 is 320 thirds. That doesn't really reduce to anything. And this is 4D. What's nice here is that the terms are kind of in pi over 3, so I can actually just subtract these straight and go, that's 280 pi over 3. And I don't believe, yeah, that doesn't divide by 3 nicely. So that's it. I'll just do it like that. And I'll cross out the, no, there we go. Okay, well, I thought these were in order of difficulty, but this one seems kind of easy for where it is on page 6 here. Although this page 6 was the first page I got from one of the teachers I borrowed from. So anyway, but it's easier than the problem we just did. Right circular cone has a radius of 5 and a height of 8. What's the lateral area? And what's the surface area? Let's do lateral area first, because surface area is just lateral area plus base. So I kind of do need lateral area first. This is half PL, and P is circumference of the base, which is 2 pi r. Now with the L. L goes here, 5, 8. I don't think that's a nice Pythagorean triangle, is it? 5 squared, seems like it ought to be, but it's not. Plus 8 squared is 89. Yeah, 189 has a, no, sorry, 289 has a nice square root, but 89 doesn't. Square root of 89 is yucky. It is the square root of 89. It doesn't say you have to leave it like this, but you know what? I'm going to, just to show you it can be done. Square root of 89 does not reduce. It does not have any square factors. Half times 2 is always nice. It goes away. I have 5 pi times the square root of 89 in exact form. It's got a radical and a pi in it. Isn't that great? So I have 5 pi times the square root of 89. Kind of actually gives you less work to do. You have a little more to write, but you know what, though? People get bent out of shape about how you can combine like terms and add stuff, and what can you add and what can you not add, and people get all bent out of shape. Okay. Plus area of base pi r squared, which is just 25 pi. I have 25 pi plus 5 pi squared root of 89. I really can't add these. I guess I could factor out of 5 pi and say this is square root of 89 plus 5, but that's not worth explaining. We'll just stop here. That one was nice. Oh, if you want decimals, if you had to go to decimal land, let's do that. 5 pi just to show you, whoops, not E, pi, just to show you that this is actually kind of legal on this one. Actually, I can just go times answer, can't I? Because I already had that in there. Okay, so 5 pi, that's 148.18. I'm not going to underline it, though, just to show you where my allegiance is. All right, and add 25 pi to that. And it's something like 226.73. In case you already did these, you just want to check, see if you did it right. There you go. What do you know? Another straightforward one. Surface area, 4 pi r squared. Don't count on having the formula in front of your face during the quiz, during the test, because you might not. All right, 4 pi, and I went ahead and took the liberty of calling this a radius already. 81 times 4 is not something I care to do in my head. Oh, it's 324, isn't it? See, I already did it. All right, 324 pi. And volume. This is really a yawner, isn't it? I should be spending my time doing more interesting stuff. 4/3 pi r cubed. R is 9. I'm just going to do this. 9 cubed times 4 divided by 3. We get, oh, that isn't that cool how that does that? It just goes backwards. I mean, I forgot about that cool property. This is 972 pi. It doesn't say terms of pi on this one, but you really should. All right, just as we have two corresponding faces on similar solids, notice how I copy-pasted this and made it look similar. It's not a great-looking drawing. It doesn't tell you which face. It might as well be this end face here. I don't know. Let's say the area of this face is 49, and the area of this face is 121. I have no idea what the dimensions are. It could be 7 by 7, but maybe not. I don't know. It could be 24.5 by 2. I have no idea. But whatever it is, this one is, they're similar, and this is how the areas compare. So what I'm able to do here is compare areas. And since it's an area comparison, I know that's k squared. So even if this isn't 7 by 7, I can take the square root of it when I go to compute the area ratio. It is going to be the square root of that, which is just 11 over 7, which is kind of a nice number. You notice how this book, and even though this isn't from the book, our book always gives you numbers that are going to come out whole numbers like this, which is kind of troubling to me, but okay. Find the ratio of their corresponding side lengths. So I just did that. That's right here. Done. And the ratio of their surface areas, which would be this one. Okay, length. I should label these. That's length. This would be area. Any area. Surface area, one face, base, lateral area, whatever you want to say. That would be the area ratio, and the volume. Volume ratio would be this one. And guess what? That's just this thing cubed. 11 cubed over 7 cubed. Is that 1331? What is that? Yeah, 1331, and this one I think I also know, but yeah, 343. There's a lot of cool symmetry in that number. 1331 over 343, and I know it doesn't reduce because of the prime factorization. It's all 7s and 11s. Okay, there you go. Okay, I got under 2 minutes. I think I can do this. Figure to the right. Well, I moved it. It's not to the right anymore. It's made up of a right square base. This looks a lot like the quiz. Find the surface area and the volume. As you know, the surface area is going to be the tricky part. Let's say that's the, there's the base on the bottom. I'm going from the bottom to the top. Then I have the lateral area of a prism. And then I have the lateral area of a pyramid. And that's it. I don't have any other bases other than the very bottom base. I think bottom to top seem to be the best way to do this. Bottom is a 4 by 4. Lateral area of the prism is not bad. It's perimeter times height, which is 16 times 4. And lateral of the pyramid is a little bit tricky. Oh, they gave me slant height. Isn't that nice? Times perimeter. What is that? That's interesting. 16 times 3. Let me do that offline. There you go, because I just have a minute left. Added up all those calculations. Volume, same thing. I'm going to add up prism from the bottom to the top. That, particularly the volume of that prism, that'll be the whole bottom squarish box, and then I'm going to add the pyramid. So this is always the easy one to sort of plan. Okay, prism is base times height, which is 4 times 4 times 4. Base is 4 times 4, height is 4. Pyramid is half, oh, I'm sorry, 1/3 area of the base times the height. Now I don't know this. This is going to be a Pythagorean theorem thing. 30 seconds. That's 3. This has to be 2. So Pythagorean theorem says that should be square root of 5. I've only got a few seconds left, so I'll do some calculation now. And here you go. There it is in exact form. That's as good as we can do. Next step is calculator, and I get 75.93. But out of time, so when I come back to these, I'll pick up from where I left off. believe. See you then.